Hello students, today we are going to see DSP controller and how to write a program for power electronics application using DSP controller. The DSP controller IC number is TMS320C2407. The first topic in this chapter is that what is the abbreviation of this TMS320C2407? Why that number is given for DSP controller, that we will see now. It's a full form of this DSP controller, or why this name has came is nothing but given as a topic called nomenclature. Nomenclature is nothing but explanation of why that TMS320C2407 is given for this DSP controller. Here that TMS is nothing but instead of TMS you can write TMX, TMP and TMS. Three options are there: TMX, TMP and TMS. But our IC consists of TMS. That means it is a qualified device. You can use this for industrial purpose. It will work properly in industrial purpose. That is why it is a qualified device. That is why this TMS has given. And then instead of TMS, if you give TMP, TMP means it's a prototype device. Prototype means it's a model of a qualified device. It won't work like a qualified device. It's a model. And then instead of TMS, if you give TMX, that means it is a experimental device. Students can do some experiments, or any researchers can do some experiment on the device. That kind of device will be named with TMX. And then 320. So 320 means it's a family number like 8085, 8086, 8051. In mobile and all, many of them used to mention Samsung S9, S10, like that they used to say. That means it is a family number. Then B or C, it's nothing but here bootloader option is available. Bootloader option elaborately we will see in the upcoming slides. Bootloader option is available in the IC what you are going to study in this chapter. Bootloader option is available. That is what it's mentioned like with B. Then what is C is nothing but CMOS technology is used in this IC. That is why C is mentioned. Otherwise, if E also can be mentioned, if CMOS EEPROM technology is used, or F can be mentioned if flash EEPROM technology is used. Like that, various technologies we can use for manufacturing DSP controller. So here we will be using C. That means CMOS technology is used. Then 240 means it is whether it is under C2XX DSP core or F2XX DSP core. It talks about core. That means here it's mentioned 240. That means this 240 is under C2XX DSP core. So your core, what core you're going to use is that C2XX core. So that core is having various architecture. So this 209, 203, 240, 241, 242, these are all having a similar kind of architecture. Then 206, 240, 241, 243, these are all having another type of architecture, F2XX DSP. Here we will be using C, then 2XX DSP means here 240, and then this means it is nothing but C2XX DSP. C already we know that CMOS technology we will be using. And then PQ is nothing but same IC which may have 80 pin IC, or same IC can be with 132 pin, or same IC with 100 pin. It depends upon how many pins are multiplex, how many pins are separately given. multiplex pin means like AD0 to AD7. That means a single pin will work for address as well as data. That many pins. So it is a multiplex pin. So you no need to give a separate pin for address. You no need to give a separate pin for data. Both the pin can be merged together. It's nothing but multiplexed. So that the number of number of pins in an IC can be reduced. That is why it is splitted like 80 pin IC or 132 pin IC and then 100 pin IC. So here we will be using PQ means it's a 132 pin IC. Then L means it's operating temperature range. L means it's a default temperature of the IC. It's work with 0 to 70 degrees Celsius. It will work. If it is mentioned A means minus 40 degree to 85 degree Celsius. So according to the country where we going to use and their atmospheric temperature and in which place we going to use, according to the temperature we have to select a particular IC. That is why this IC is named like this. This is called TMS320 device nomenclature. Then now we will be seeing architectural overview of TMS320 family. So this TMS320 DSP controller is having two event manager named as EVA and EVB. What is event manager? Let us consider let us consider we will be filling a gas cylinder per day as 1,000 gas cylinders in an industry. Nothing but filling gas cylinder is an event. A device or a part of a DSP controller which will take care of how many cylinders are filled in a day, which will be take care. That means it is managing, and if you wanted to count that, it is nothing but event is nothing but how many device you are filling, how many cylinders are getting filled per day is nothing but an event that you wanted to count. That means you need a manager to monitor this event. So event manager. So a part of a DSP controller, event manager A, event manager B, these things will take care of example called how many cylinders are filled in a day. That will be taken care by the event manager. Similarly, speed of a motor has to be maintained with a rated speed like 1500 RPM. It's a maintaining a speed is nothing but an event maintained by a device is called event manager. So 1500 RPM to maintain a motor, we have to give various triggering pulse for the converter, which will give a different voltage in order to maintain speed of a motor. So this kind of operation can be done with the event manager. So for this, event manager requires a few more units. So event manager is a one part of DSP controller. Event manager requires few other units for completion of this event manager operation. So now we will see what are the various units available in event manager in order to perform various tasks for the automation. So the second point, it's mentioned that event manager consists of two general purpose timer. GP timer we used to mention like GP timer. So the GP timer are split as timer 1 and timer 2, two timers per event manager. So EVA is one event manager A, and then EVB is nothing but another event manager. So per event manager consists of two timer means EVA consists of timer 1 and timer 2, EVB consists of timer 3 and timer 4. Totally 4 timers for two event managers. So per event manager consists of two timers, timer 1 and timer 2 for event manager A, timer 3 and timer 4 for event manager B. This DSP controller TMS320 IC is specially made for digital motor control. Is specially made for digital motor control. So digital motor control means we have to give various triggering pulse for the converter to control the digital motor. speed or torque, anything. If you wanted to control, a converter has to be placed or controller has to be placed so that you can control the digital motor control. So that controller has to provide various PWM signal, pulse width modulation signal. Various pulse width modulation signal only can able to maintain digital motor control, speed or torque or anything. If you wanted to control current, voltage, everything can be done with pulse width modulation signal generation. For that you need a PWM generator. Then it requires the event manager requires analog to digital converter, because analog is nothing but the speed of a motor is nothing but a analog signal, but the processor requires a digital signal. Then only you can do this speed control or anything to be controlled with digital. You need a digital signal, but the physical quantities and all like speed, torque, all those things and all analog signal. So that event manager to perform any event managing, it requires analog to digital converter. It has a 10-bit analog to digital converter, this DSP IC. Then controller area network interface, CAN network. It used to say CAN network. What is the purpose of this one is, if you have a multiple processor, in that there will be one master processor and then few slave processor will be there. While doing communication between these master processor and slave processor, we need a proper network in order to have a proper communication without doing any malfunction, because sometimes the slave processor will give some signal which is opposite to the master processor. Then what will happen is that the device will not obey for the master processor if you don't have a CAN network. A CAN network is there means that CAN network will give you highest priority for the master processor and least priority for the slave processor. Even though the slave processor and master processor at a time, if it gives a different signal at a time, it gives a different signal, it will obey for the master processor, because a controller area network will take care of this malfunction avoidance. So, for example, let us take a car. In the car, driver side window control is there. Similarly, passenger side window control also is there. But driver is having a control of driver side window controlling as well as passenger side window controlling. But the passenger doesn't have the control of driver side window control. Only passenger side window control is having. So the driver side controller is having it is a master control. The remaining thing and all called as slave control. So the person who is sitting behind the driver in a car tries to open the window, but the driver wants to close the window. So at a time both are giving same signal, means driver side signal only given to the window in the passenger side. So what will happen? The door will be in closed position. It won't go to the open position. That means master controller is having more control than the slave control. This will be taken care by controller area network. I hope you have understood this controller area network, which is required for this event manager. And then serial peripheral interface, SPI. This will do synchronous communication between DSP and then any external devices. That is why external device is nothing but peripheral interface. So this DSP and the external device is going to work with the same clock frequency. That is why it is called as synchronous communication. So synchronous communication can be taken care by serial peripheral interface. This communication will be takes place between this DSP and the any input output device which is connected with the DSP. So this serial peripheral interface will work with the same clock with the external device. If you wanted to communicate with the DSP and the external device in asynchronous mode. That means both are not working with the same clock frequency. This communication will be taken care by the next point called serial communication interface. It is mentioned that asynchronous serial port. Asynchronous serial port means which will both the device is going to work in different clock frequency. And then the next topic is general purpose bidirectional digital I/O, GPIO, general purpose I/O pins. These GPIO pins you will see elaborately in the upcoming slides. GPIO is nothing but general purpose bidirectional input output pin. Why it is bidirectional means it can work as input as well as output. Simply you can send some data via this pin and you can receive some data via this pin. Then at last, the event manager, it consists of the DSP consists of Watchdog Timer. Watchdog Timer is nothing but this Watchdog Timer. For example, that name itself suggests that it is going to work as a dog. Because a dog will watch if any unwanted things happen, it will give you signal. The same thing. If a user, let us check, you will be using your laptop or system. If you are using the system, it will not go to what power saving mode. If you are not using the system, you went somewhere for 1 hour or 2 hours. While coming back to use the system, it will be goes to the power saving mode. That means that monitor does not show any screen what you are using earlier. That means monitor power will be it won't consume, so it goes to the power saving mode. That is why it is called as Watchdog Timer. It will be keep on watching. If the user is not using anything on the system, like he is not using keyboard or mouse, if he is not giving any signal, input signal to the system, what it will understand that no person is there in the system to work, so it can go to what power saving mode. For that, that Watchdog Timer is used. This is the architecture of TMS320C 2407 IC. It consists of various memories like ROM and DRAM and DRAM. DRAM is splitted as B0, B1/B2. What is DRAM? You know about ROM and flash EEPROM. ROM means read-only memory. What is DRAM? DRAM is nothing but dual access RAM. Dual access RAM is it's a memory. That memory blocks are splitted as 3 types: B0, B1, B2. B1 and B2 always used for data memory. The data memory is nothing but where you can store input and output data. For if you're going to do input addition of 2 number, the 2 number where you have to give is nothing but in DRAM. Let us take 2 plus 5. That 2 and 5, these two will be given in DRAM, B1 and B2. And then after doing addition, that answer 2 plus 5 is nothing but 7. That also will be stored in DRAM B1 or B2 block of memory. So B1 and B2 is only for storing the data. That is why it is called for data memory. DRAM is nothing but dual access RAM. Why it is called as dual access RAM? Another RAM also is there called as SARAM, single access RAM. Single access RAM, what it will do? It will first we need to know what is a dual access RAM. Dual access RAM is nothing but per pulse, per clock pulse, it will do write and read operation double the speed of single access RAM. So what I am saying is that let us take 1 clock pulse. It will take some time period. In that time period, that dual access RAM will do faster operation, double time the faster operation than the single access RAM. So single access RAM will not allow you to access it quickly. Let us take an example. In early days, olden pen drives and all will be used with single access RAM. So that is why we have to give more time to copy or retrieve some data from the pen drive. But nowadays the pen drive is having a dual access RAM. So within a short period of time, you can get the data from the pen drive, or you can load the data on the pen drive. So that is why this dual access RAM is used. The same thing, B0, DA-RAM, B0 is there. DA-RAM, B0. B0 is a block 0. Block 0 is nothing but it is also one part of the memory, but B0 alone can be used, can be configured with data memory or else program memory. But B1 and B2 always for only for data memory, but B0 can be used, can be configured for data or else program. If CNF bit, that CNF bit will be, you can see later, CNF bit, nothing but if it is 0, that B0 can be used for data memory location like B1 and B2. If that CNF configure, CNF is nothing but configure bit, if it is equal to 1, that B0 can be used for program space. Program space means like if you wanted to do some addition of two number, add A comma B, this operation is nothing but program space. This program space take two numbers, move A comma B, move this data to that register, like that. If you are saying, these are all called as program. This program space and all will be taken care by B0 if CNF bit is 1. I hope you all understood this memory part. Now we will move on to the instruction register. Instruction register is nothing but where you can see the next address of next instruction to be executed. If two lines are there, first line is executing, means the next line is going to come for the execution process. That when it is executing the first line, the second line program address is available in the instruction register. And you can see this part is nothing but C2XX CPU. It is a main core C2XX CPU we were using. Then ARAU. This ARAU is nothing but auxiliary register arithmetic unit. Auxiliary register arithmetic unit. This one is used for direct addressing. When you're going to see various types of addressing modes of TMS320 IC, you can see the use of this ARAU unit. Then status and control register. Status and control register is nothing but here only you're going to load that value CNF bit is equal to 1 or 0. That means what? You are controlling the B0 whether to be used for data memory or program memory. That control and all can be done. That CNF bit will be available in this control register. And status register is nothing but at present your DSP processor is what it is doing, whether it is writing or reading or fetching some opcode, all those things you can see with the help of this status register. Then auxiliary register. Totally 8 auxiliary registers are there. AR0, AR0 to AR7. Totally 8 registers are there. Those registers are used to point the memory location of a content. So that memory location 16-bit will be, that memory location means address, that 16-bit will be available in AR0 to AR7. That means either in AR0 or AR1, anywhere you can load the address. So this can be used for indirect addressing. So it is nothing but it's a register. We know that in indirect addressing and all, directly the address won't be given. Where the address will be, it will be in a register. First you have to go to the register, get the data, that means get the address. In that address some content will be there. This is nothing but indirect addressing. So similarly here for indirect addressing, this AR0 to AR7 will be used. In AR0 or to AR7, the memory location somewhere it will be that auxiliary register 0 to auxiliary register 7. If you wanted to access, you can use 000 means in a bit in a control register. If you use a 000 na, it will access AR0. 111 means it will access AR7. Like that you can access the AR0 to AR7. Then in that some address will be there, a 16-bit address, because this auxiliary register can carry a 16-bit address. That 16-bit address you can retrieve. In that one content will be there. That content only you have to use for the purpose of the program. So this is used for indirect addressing. And then input shifter. Input shifter is nothing but user is giving some data. Let us take 02. 02 can be mentioned with the 8421 code is nothing but 0000, then 0010. So 02 is the input with 8421 concept. If you mention 4 zeros, then 0010. If you wanted to get from this value of 2 to 4, this 2 I wanted to convert as 4. What I should do, this 8-bit value 02 can be shifted one time left, means what will happen, that 2 will be converted as 4. You can check this one, how. Just shift one bit towards left side. Write this in your notes. Just write 00000010, nothing but 02. Towards left side you shift all the bits. That means what will happen, that 1 will shift to left side, remaining and all zeros, nothing but if you calculate with 8421 logic, it becomes 04. One more time if you shift towards left side, you will be getting what, 8. Nothing but from a given input you can get some other value with the help of input shifter. According to the program requirement, we will use this input shifter. That means the given input by the user itself can be modified with the help of input shifter. Then next one, ALU. We are all aware of this ALU, arithmetic and logic operation and all can be done with ALU. Then accumulator. Here accumulator is used. Accumulator is the purpose of loading one of the value for manipulations. And accumulator here we are using 32-bit accumulator. It is split like higher order accumulator and lower order accumulator. Higher order means 16 to 31. Then lower order means 0 to 15. So totally 32 bits, 0 to 31. That is split like higher order and lower order. So 32-bit accumulator we are using with DSP controller. Then output shifter. Again, it is similar to your input shifter. Once the answer, if you got some value, you want to modify the output shifter. So sorry, that output, the result as came, that I wanted to modify. Like again, take an example. I am getting answer as 2. I wanted to shift. I wanted to get answer to be 4. Then what I will do, I will shift one time towards left side. I'll be getting 4. So this process, once if you do a operation with the program, then you will understand clearly why this output shifter and input shifter are required for the purpose of the program. And then multiplier. Multiplier is nothing but which will multiply. It consists of 16 cross 16 multiplier, and it has TREG. TREG means temporary register, and PREG product register. The multiplier gives you the output 16 cross 16 output. It will do 2's complement multiplication. Then that one of the value, if you wanted to do multiplication, minimum 2 numbers you required. One number must be there in TREG, temporary register, and the answer will be stored in product register, PREG. After doing multiplication, finally the answer will be available in product register. Before moving the product register output, that means that multiplier output, to reach the central ALU, if you wanted to shift that answer also, then I'll be using product shifter. This product shifter only purposely specially given for multiplier output shifting. This is not like your output shifting. That output shifting is for other arithmetic operation than multiplication. So this product shifter will shift only the product output of multiplier. Then next one is memory mapped register. Memory mapped register is your memory content can be used for your peripheral. That is nothing but a peripheral requires some address. That one you can use it for memory. Our memory address specially you are going to use for only for the memory. Then this process and all can be taken care by memory mapped registers. Then next one, test slash emulation. Test slash emulation is nothing but you know that this is your DSP core CPU. So this IC has to be connected to a PC. PC means your computer, personal computer. Because if you wanted to feed some program on the DSP IC, you have to connect. You will be writing the program in the CPU, and that will be there. That will be there in the system. That program has to be loaded to the DSP. Means you need a mediator connector. Then only that DSP program which is available in the computer has to be transferred to the DSP IC. For that, we required test slash emulator block, which will convert the program which is available in the computer CPU, that will be transferred to the DSP CPU. Then external memory interface. Already this DSP is having ROM and then DRAM and then DRAM B1, B2 blocks. If you required more memory space, then via this external memory interface block, we can connect few more memory segments with the DSP processor. Then software wait state generator. Software wait state generator is nothing but this is used for generating wait state in the DSP processor with the help of Code Studio software. Code Studio software is nothing but in the system we will be using a software called Code Studio software. There only we will be typing the program. Using that program software, we can control the program available in the DSP with the help of software wait state generator. Then now we will come to the main part of the DSP processor called event manager. This event manager only it's going to do multiple operations for your DSP processor, because this event manager only it's going to do digital motor control. For digital motor control, we need to generate PWM. For generation of PWM, we required timers, general purpose timers. So your event manager consists of 4 timers, timer 1, timer 2, timer 3 and timer 4. So 4 timers are there. And then compare units. Compare unit means by comparing 2 signals only, you're going to get PWM pulses. So for that you need compare unit. 2 signal comparison, all those things you can see in the program of PWM generation using timer 1. There you can understand why compare unit is required. So by comparing two signals, we will be getting a PWM signal. That PWM signal only we will be applying to the applying to control the digital motor. Then capture and quadrature encoder pulse, QEP, capture / quadrature encoder pulse. Capture unit means at present what is the motor speed I wanted to capture and show to the user. That can be done with capture unit. And similarly, the quadrature encoder pulse it's a circuit which will sense the speed at present speed of the motor as a various pulse. That speed is converted as various pulse. That pulse will be given as a input for the DSP, so that the DSP will identify what is the difference between set speed and the current speed. So the current speed is given as a multiple pulses. Speed is converted as pulse with the help of quadrature encoder pulse. That pulse will be given as an input for the DSP. So DSP is already having some set speed. That set speed will be compared with given pulse from the quadrature encoder pulse circuit. Accordingly, the error speed will be generated. Accordingly, the speed of the motor will be controlled by generating required PWM signal. Then you know about a program controller. Program controller will control what line has to come, whether it has to jump to some other address or whether it has to come to the subsequent address. All those things can be controlled with program controller. Then this system interface module is used to connect various input-output devices. Input-output devices with DSP controller. But these input-output devices are inbuilt inside the TMS IC. It is not the external device. It is a device which can be used as a optional, but it is available inside the DSP processor. Usually this units and all, this ADC, then serial peripheral interface, the serial communication interface, watchdog timer, these units and all won't be available inside the processor in other processor. But this specially made IC for digital motor control requires A to D, this serial peripheral control, then serial communication interface control, watchdog timer, all those things within the DSP controller for digital motor control. Already I told you 10-bit ADC is required, then serial peripheral interface in order to communicate with the external device, and then serial communication interface you use to communicate with a device which is working with some other clock frequency than the DSP controller. Watchdog timer is for power saving mode. Again, this clock module is nothing but used to give clock frequency input for the DSP processor. We know that DSP processor not only requires supply, also it requires clock frequency, because supply will decide whether to work or not. If you don't give supply, the DSP processor will not work. If you give supply, it will work, but at what speed it has to work will be decided by clock module, clock frequency. I hope you all understood this functional block diagram of TMS DSP controller IC. And I already told you, event manager A, event manager B, two event managers are there. That event manager A block diagram alone, here it is displaying. In this, already told you, event manager A consists of two timers, general purpose timer 1 and general purpose timer 2. General purpose timer 1 will able to provide one PWM signal. PWM. Timer 1 PWM or timer 1 compare unit. So similarly, timer 2 can produce only one PWM. Timer 2 T2 PWM, here T1 PWM, here T2 PWM. So if a program, if you wanted to write a program, generate a single pulse PWM using timer means you can use a timer 1 or timer 2, because this timer and all can produce a single PWM, and timer 2 also can produce a single PWM. If they are asking you to generate 6 PWM, here you can see PWM1 ... means PWM2, PWM3, PWM4, PWM5, at last PWM6. So 6 PWM signals can be generated with the help of full compare unit with deadband circuit. So this full compare unit with the deadband circuit can generate 6 PWM. But timer 1 can generate only 1 PWM. Timer 2 also can generate 1 PWM. And event manager A consists of timer 1 and timer 2. Event manager B, we will see in the next slide, that will consist of timer 3 and timer 4, that we will see in the next slide. This output logic, it is used for whether the PWM signal has to come or not. That can be decided with the help of output logic. If you deactivate this output logic block means, even though the pulse is generated with the help of full compare unit, PWM state machine, and then deadband unit, output will reach this point, but it will not reach the output pin. So with the help of output logic, you can activate or deactivate the signal which is generated by the full compare unit. Similarly, here also the output logic is there, which is used to activate or deactivate the output, whether to come outside or not can be decided with the help of output logic. Here also the timer 2 output can be controlled with this. Here this timer 2, it's a compare unit. Here timer 1 compare unit, because for comparing two signal, then only you can able to generate a PWM signal. So timer 1 will use compare unit, timer 2 will use timer 2 compare unit. Similarly, here a capture unit is there. This capture unit comes out from timer 2, also from timer 1. So if you wanted to know what at present the timer value 1 value, that means that mux will be controlled to give either mux means multiple input single output, whether to give timer 1 value or timer 2 value will be controlled with 0 and 1. 0 means timer 1 will come, 1 means timer 2 value will come. That mux operation already you know that. So timer 1 and timer 2, any one value will come out here. That value at present, let us take the timer is counting from 30 to 0. Decrement counting, 30 to 0 means 29, 28, like that it will count. So at one point of time you wanted to know what is the at present value of the timer. So that value will be captured with the capture unit, and it can be displayed in the display for the user purpose. Similarly, here quadrature encoder pulse circuit, QEP circuit is available. This QEP circuit, already told you, it is used for digital motor speed sensing, and it will convert that speed into multiple pulses, will be given as a input for the timer. that pulse will be calculated with the timer, because every pulse will be counted and that will be given as a signal for the DSP controller, so that the DSP controller already having some set speed. This speed converted into pulse will be given to the timer. The timer will count according to the pulse, how many pulses are came from the quarter chain and quarter pulse. That count will be given as a speed signal for the DSP processor. So again, that will be used to control the speed of the motor. And then similarly, this portion or whatever we have seen, these portions are used to control the speed. Similarly, sometimes we have to use to convert that analog signal into digital signal. So for that, we have to start the ADC. So for that, this block will be used: EV, control register, and control logic. So some event, let us take once the value while counting from 30 to 0, at 15 you have to start converting that analog signal into digital. So after 15 seconds, you wanted to start the, you want to operate the analog to digital converter. Means what you load, let us say you load 30. The 30 is decremented to 29, 28 like that. Once if it reaches 15, automatically the signal for analog to digital converter is given, so that the analog to digital converter will start converting the analog signal, and then it will be converted into a digital signal. Then here prescaler is there. Prescaler means whatever clock frequency you are giving to the processor, according to the work given for the processor, it will work. If you are not going to give multiple tasks to the DSP, then the DSP has no need to work quicker, because it has very less processor, less content to do. So it no need to work in high speed, because if it works in high speed, obviously it will take more power. So if it takes more power, it is a unnecessary power wastage. So that prescaler, according to the value, you will be giving in timer 1 control register. This and all you will see in the upcoming slides. Timer 1 control register, 8th bit, 9th bit, 10th bit. That is why here 8, 9, 10 is mentioned. This T1 con 4,5 will control this mux. So this also you can see whether to enable or disable this clock signal is decided with the help of this mux. This mux is controlled with the timer 1 control register, 4th and 5th bit. Here prescaler, already I told you, prescaler will change the clock frequency input to the timer as well as for the DSP controller. At what speed it has to work, whether it has to work with 2 megahertz or 4 megahertz or 6 megahertz or 8 megahertz, that and all can be decided with the help of prescaler. Pre-scaling. Pre-scaling means pre means before itself, before giving the full frequency, whether to give low frequency or high frequency of operation of GP timer and DSP controller will be controlled with a prescaler. This prescaler is for controlling the timer 1 operating speed. Here this prescaler is used for controlling the GP timer 2 operating speed. Again here it's mentioned T1 con 8, 9, 10 bit. Here timer 2 control register 8, 9, 10th bit. So if you see these registers in the upcoming slides, you can understand how they are controlling the clock frequency of the timer 1 and timer 2. Here T2 con 4,5. And the capture output, whether to come out or not, can be decided with cap con A. Cap means capture, con means control, A. So in that 13th and 14th bit are used to control this mux. Similar kind of structure you're going to see in the next slide, but that is for event manager B. This one is event manager A. Already told you, you have to use timer 3 and timer 4 for timer 3 and timer 4 for event manager B. Similarly, capture con B you have to use for event manager B. There in event manager A you are using capcon A, capture control A register. Here for event manager B, capcon B you will use. Remaining and all it is similar. What is this Csv Pwm State Machine means? If you wanted to generate space vector PWM. Space vector PWM is a special PWM which you can study in powertronic subject. That special kind of PWM, if you generate, it is totally different from normal PWM 1 to PWM 6. This special PWM generation, space vector PWM, will be used to control the harmonics output of any converter. So this kind of PWM is specially used to control the ripple. So if the ripple or harmonics is reduced, obviously the efficiency can be improved. But here in this chapter we are not going to use space vector PWM. The same space vector PWM state machine is there in the event manager A also. Then in event manager A it is mentioned that PWM 1 to PWM 6. Here PWM 7 to PWM 12 you can use. So totally with the DSP controller 12 PWM signals are generated with the help of combination event manager A and event manager B. Event manager A will generate 6 PWM and event manager B will generate another 6 PWM, totally 12 PWMs, and then timer 1 can generate 1 PWM. So totally 4 timers. So 4 timers will generate 4 PWMs. So obviously totally if you add together 12 plus 4, 16 PWMs you can generate with the help of this DSP IC. Remaining blocks and all similar to your event manager A. Already I have explained about the various blocks: event manager A, event manager B, ADC converter, and I have explained clearly about CAN module, then serial peripheral interface and serial communication interface. Then Watchdog Timer also I have explained. It is mentioned that power saving mode. You can see that. Here, if the software enters an endless loop means the user has went somewhere, it will be keep on showing a same screen, nothing but it's an endless loop. So Watchdog Timer will overflow and DSP reset will occur, will cause the DSP program to branch to the initial starting point. So in this way, the Watchdog Timer increases the reliability because you are reducing the power consumption. So it is obviously the reliability is increased. And then general purpose bidirectional input output pins, those things you can see with this mux control MCRA registers. You will understand clearly with mux control register, MCRA, MCRB, MCRB, those registers can be used for understanding of this GPIO pins. Then joint tag action group, JTAG port. This one in the architecture you have seen test/emulation. Test/emulation is used to, it's a module where you can use for connecting a DSP with PC, personal computer. So in order to program the DSP using personal computer, that is what here it's mentioned. Personal computer to DSP connection scheme. This is nothing but your DSP IC. Here emulator pod, then computer. So your computer is connected with the DSP with the help of this JTAG port. This is nothing but your JTAG port. Then Pll Clock Module. Pll is nothing but phase locked loop module. For this is for input clock multiplier. Input clock multiplier means whatever the clock frequency you are giving for the DSP, if you wanted to increase the clock frequency of the DSP core, you can do that can be done with the Pll Clock Module. So that if you increase the clock frequency, you can get the operating speed of the DSP processor is getting increased. So 0.5x to 4x can be done. 0.5x, 0.6, 0.7 like that up to 4x. 0.5x means the given clock frequency. Let us take 6 megahertz frequency is nothing but x. So 6 megahertz into 0.5 means it is divided by 2. So that means the given clock frequency is divided by 2. So that because it is not going to work with multiple operations, so it does not require to use more high clock frequency. That is why that that 6 megahertz x is divided by 2. That means into 0.5. So if the processor is has to do operation in higher speed, then the same 6 megahertz x is multiplied with 4. So that 6 into 4, 24 megahertz frequency that processor is now it's going to work, so that that operation can be done quicker than the expected one. Then various memory allocation spaces are there. Various memory allocation space, already I told you, the dual access RAM, single access RAM and all is there. That RAM are going to be used as off-chip RAM. Off-chip RAM means whether that memory can be used externally or can be used as internal memory. Even though it is available inside the DSP processor, you can utilize that as a external memory. How it is possible is that MP bar MC mode. MP bar MC mode means MP means microprocessor mode, MC means microcontroller mode. We know that microprocessor doesn't have internal memory, microcontroller has internal memory. So that available memory inside the DSP controller, whether if you select that MP bar MC pin as 0, MP bar MC bar MC slash MP slash MC MP slash MC bar is equal to 0 means you are selecting microcontroller mode, because MC bar means it is active low. Here I have given 0. That means I am going to use the memory as internal memory. It's not a off-chip memory, it is on-chip memory. If I select MP slash MC bar pin as 1, that means I am going to use it as a microprocessor mode. Microprocessor mode doesn't have any internal memory. So internal memory means obviously the inside memory content can be used as external memory. So on chip or off chip that can be mentioned with the memory allocation space bit called MP bar MC pin. Then various types of physical memories are available. RAM, already told you, dual access RAM, that will be split as B0, B1, B2. That can in that B1 and B2 are always for data memory. B0 with the help of CNF bit. If CNF is nothing but configuration bit, already I have explained in the previous slide. CNF is nothing but configuration bit. that will configure only B0. B1, B2 always for data memory. B0 can be configured for data memory. If CNF bit is 1, B0 can be used for program memory. Similarly, SARAM. SARAM is nothing but single axis RAM. Already told you, single axis RAM means it is allow you to access the memory slower than the dual axis RAM. Dual axis RAM, you can within a single pulse double the speed of a single axis RAM. You can access the memory content. So you can transfer or you can receive from the memory or to the memory quicker than the SARAM. Then non-volatile flash memory. Non-volatile flash memory means even though the power supply is not available, it won't be getting erased. The content available in this memory will be available always, even though the power supply is not there. Mostly where we will use is that, for example, this IC is used to develop a DSP control solution for automobile braking system. Let us take this IC is kept inside the car. So we cannot connect this IC always with a system which is PC, personal computer. Personal computer will be there in office or home. How can we connect this personal computer with a cable which is with DSP controller, which is going to travel along with the car? So that automobile device will travel anywhere, but I can't take that cable along with which is connecting with DSP and the PC. So that is what here it's mentioned. DSP JTAG PC interface is not possible to travel with the car. So in that kind of condition, I required non-volatile memory where you can store all the data, so it can be portable. Then software tool, software wait state generator you have seen in the architecture. There Code Composer Studio. This Code Composer Studio is a software, user-friendly software where you can use in the system so that you can program in that. That program can be, with the help of JTAG, can be loaded to the DSP IC. Then here the various components of C2XX DSP core. You can see already I told you when I'm explaining the architecture, it has 32-bit central arithmetic logic unit, CALU. Then 32-bit accumulator. Already I told you 32-bit accumulator is split as 16 and 16. And then input shifter, output shifter, all those things you have seen in the architecture. 16 cross 16 multiplier also is there. And a product scaling shifter is for only for the purpose of shifting the content from the multiplier. And then AR0 to AR7 various action registers are there for indirect addressing. That also I have explained when I'm explaining the architecture. This accumulator content, and then scaling shifting. Scaling shifting elaborately we can see here. Input data scaling shifter. Let us take a program line called add 300h, 5. This is a program line you can see in the DSP processor program. What is the meaning of this program line is that 300 is nothing but the address, memory address. That memory address in that one content will be there. That content will be added with the accumulator content. But input shifter is responsible for first shifting the data in the memory address. So what will happen is that in 300 one data will be there. Let us take 02. 02 is nothing but 0000. 0, 0, 1, 0. This 0, 2 is going to be left shift for 5 times. That means that 1 will be shifted 5 times. So the value will become the value will become 40. Initially, its value is 02. Now, if you shift that value 5 times towards left side 40, it becomes 40. You can do that left shifting of 5 times. You can see that one will be shifted towards left side. That means that input value 2 is shifted towards left side for 5 bits, so that the value becomes 40. That 40 now can be added with the accumulator content. That is what it's mentioned. Add 300H, 5. That 5 means shift the given input towards 5 bit. You can mention with 1 bit also. That is also possible. If you put 1 here, it will do 1 bit shifting. That means 0, 4 you're going to add with the accumulator content. Now that 0, 2 is shifted towards left side for 5 bit, so that it becomes 40. So 40. That 40 content will be added with the accumulator content. So this is what the explanation for add 300H, 5. Then output data scaling shifter. Output shifter. Here the program line called SACL 300H, 4. Here what it means is that first the accumulator content is getting shifted towards left side by 4 places, because here in the program it's mentioned 4. So before storing the content, what is the meaning of this line is nothing but store the accumulator content in the address of 300H. Before storing, shift the content towards left side for 4 bit and then store it in address of 300. Similarly, product scaling shifter, whatever the output comes from the multiplier will be available in the PREG, product register. Before moves to the CALU, that product shifter has to be shifted. In that, various shifting operation is there, like no shifting, left shifting by 1 bit, left shift by 4 bit, right shift by 6 bit. These operations only can be done with the product register. As our wish, you cannot do 2 bit shifting, 3 bit shifting like that. Either you can do no shifting, or 1 bit shifting, or 4 bit shifting, or right side 6 bit shifting. These are the various operations of shifting can be done with product shifter. And already you know that a multiplier consists of it will perform 16-bit 2's complement multiplication, and the answer will be 32-bit result. One value should be in temporary register and the answer will be available in product register. This auxiliary register arithmetic unit, which is available in the architecture of this TMS IC. Also, this various auxiliary registers are already told you, AR0 to AR7. These are all going to be used for memory addressing. Uses in indirect addressing for accessing the data. So now we will see what is system configuration register. What is system configuration register is which is used to configure or display fundamental settings of this DSP IC. LF2407 is nothing but your TMS320 LF2407. That full form IC they have given as LF2407 IC. This whether it is going to work in the memories are kept in microprocessor mode or microcontroller mode. Whether the B0 is mapped for data or program, these can be done with this system control and status register 1, and its register address is 7018H. 7018H. Here we will be having totally 15 bits, 15-bit register. 15, 14, 13 like that up to 0. Each and every bit we will see in the next slide with clear explanation. 15th bit is reserved for future development of this DSP IC, and 14th bit is clock output pin. If it is 0, the clock pin as CPU clock of 40 MHz. If it is 1, the clock out will not be 40 MHz. What the clock frequency which is generated by your Watchdog Timer, because CPU clock is different from Watchdog Timer. CPU will work in some other speed, Watchdog Timer will work in some other speed. Both will not work in same speed. So your clock output, either your CPU clock output or Watchdog Timer clock output will be decided with the bit 14. So Watchdog Timer, if it is working with 6 MHz, let us consider as an example, and your CPU is working with 40 MHz. If the bit is 1 means your clock output is connected with 6 MHz. If the bit is 0, the CPU clock will be giving you 40 MHz, which is CPU clock. And then bit 13 and 12, which will be used for low power mode selection. Already told you during if it is going to do multiple tasks, the CPU has to work and various units of CPU, whether it has to work or not, those things can be controlled. So the power consumptions can be reduced. This is nowhere related to your Watchdog Timer. This is according to the work assigned, whether it is a tougher work or smaller work, all those things, which part of the circuit has to work, remaining part is going to be ideal, means we no need to give supply for that. So that supply power consumption of the devices can be controlled with the help of this LPM. LPM means low power mode selection. Here you can see whether the bit, if the bit is 00, that means your CPU clock status will be off. That means CPU clock will not be working. Remaining system clock, then Watchdog Timer clock, then Pll clock, phase lock loop clock, then oscillator clock, all those things going to be on. And then ideal, this is under ideal 1 mode. Ideal 2 mode means here the bit should be, this 13 and 12th bit should be 01. That means CPU clock will be off, then system clock also off, remaining and all on condition. So at that time, how much ampere you are saving, how much current it takes, those things you can see. How much current it reduces. Here everything is off. That means it saves this much supply. Pll down. This is another third mode where if you select 10, these two will be off, and these are all, and this is on, and this is off, and this is on. So that various mode of operation, various unit, whether it has work or not, all those things can be decided. And then Pll Clock Prescaler select. whether the phase lock loop unit already we have seen in the explanation, PLL clock explanation. It can produce 0.5 frequent 0.5 into x. There it's mentioned x, here 0.5 into the input clock frequency to 4 into clock frequency. These things will be decided with the help of 11 to 9th bit, 11 to 9, 11, 10, 9. These 3 bit are 0, 0, 0 na. Your clock frequency will be 4 into input clock frequency. If it is 0, 0, 0, 1 means 2 into input clock frequency. 0, 1, 0 na 1.33 into input clock frequency. Like that you can select which clock frequency the PLL has to work. Then 8th bit will be reserved for future purpose. Then 7th bit is ADC, whether your analog to digital converter you going to use or enable or disable, those things can be mentioned with this 0 and 1 in bit 7. 0 na that ADC clock module, ADC is required, any clock module or not. If clock signal is disabled to the ADC, means that ADC will not work. If you wanted to start the ADC, the clock has to be given. For that, you will be giving 1 in bit 7. Similarly, whether serial communication interface unit has to work or not, that can be enabled or disabled with the help of bit 6 by writing 0 or 1. Similarly, serial peripheral interface enable or disable, and controller area network, everything requires clock frequency. Whether you're going to give clock input or not can be decided with the help of these bits. Similarly, event manager B, event manager A module has to be work or not, all those things can be decided. Bit 1 is reserved for future purpose. Bit 0, this is the last bit where you can identify if any illegal address is given by the user, then this bit will be set. Then next register is system control status register 2. System control status register which has the address of 7019. The 7019 in this 15th to 8th bit are reserved. Up to 7 also it is reserved. From 6 to 0 bits explanation we will see in the next. Here 6th bit will show this bit determines the width of the glitches. Width of the glitches means how the clock pulses are coming. Particular time how many clock pulse has came. If you wanted to determine glitches means how many clock pulses, the input qualifier circuit blocks glitches up to 5 clock pulses. So 5 clock pulses if you wanted to block, you can put 0. If you wanted to block 11 clock pulses, then you have to put 1. So 5 clock pulses to be blocked by a circuit, that can be decided by writing 0 on bit 6. If you write 1 means 11 clock pulses will be gets blocked. Then watchdog timer. Watchdog timer protect bit. Whether the watchdog timer in some systems, if you disable the watchdog timer means what will happen? It is going, your system is going to consume more power. That means even though if you are left from the system where you are using, it will be keep on showing the same thing what you are displaying on the system. It will not go to power saving mode. So enable or disable of watchdog timer also can be done with this register with bit 5. So if you write 0 na, that means you cannot disable the watchdog timer. It protects the watchdog timer from being disabled by the software. So Whatever you are doing with the software, Watchdog Timer will not be disturbed if you write 0. If you write 1, you can disable Watchdog Timer with the software. Then XMIF, IZ. This IZ is nothing but I impedance. Z means impedance. XMIF means external memory interface. X means external. M means memory interface. So, your external memory interface means if you're going to connect your external memory with the DSP. Let us consider your external memory is connected with the DSP. Whether any signal has to be transferred to the external memory, or any signal you want, any data from external memory you required, that connection should not have high impedance. High impedance means it will not allow any signal transfer. So if it is low impedance, that means signal can transfer. We all know that if resistance is more, current cannot move. If resistance is less, current can move. Similarly, here if impedance is more, data cannot be transferred from external memory to DSP. So if it is 0, it is normal driven mode. That means you can transfer the data from external memory to DSP or DSP to external memory. That means not high impedance. If it is 1, forced to high impedance, you cannot transfer any data from or to the memory from DSP or DSP to memory. Then already I told you that when I'm explaining a nomenclature of TMS320 IC, B is boot loader is possible. Here bit 3 is showing that boot enable is possible with LF2407. You can see this pointer. If it is 0, there is no on-chip boot ROM. So booting ability cannot be done with 0, that to this IC, with this IC, LC IC, not LF IC, with LC IC, LC series IC. If it is 1 means disable boot ROM. That means on-chip flash memory in the case of LF2407. That means it has that this LF240607 is having on-chip flash memory for boot ROM. Then bit 2. Bit 2 can be selected for microprocessor mode or microcontroller mode. Microprocessor mode means it doesn't have any internal memory. Microcontroller mode means it has internal memory. So here we are talking about DSP only, but in terms of microprocessor mode or microcontroller mode. Here if it is 1 means what you going to select? Microprocessor mode. Microprocessor mode means external memory. 0 means internal microcontroller mode. And bit 1 and 0 start single access RAM. It can be used for program / data space. So your single access RAM, whether you're going to use as internal memory or external memory, that you can select with this. External memory, this data and program both are not going to be used for internal memory. That means it is used for external memory. So your single access RAM can be used for external memory. If you're going to use the single access memory for internal storage again, whether this single access memory can be used for data memory or can be used for program memory or can be used for both purpose, program as well as data, can be decided with if it is internal, these 3 options are there: program memory or data memory, program or data, or program as well as data. If it is 0, 1, that means it is going to work as program memory. 10 na it is going to work as data memory. 11 na both. This B0, B1, B2 concept and all of concept of memory and all already we have seen 3 main blocks. And here we'll be seeing that LF2407 IC has 544 16-bit words of on-chip double access, dual or double access random access memory. This B0, B1, B2 and all already we have seen. And SA memory, single access memory, how many are there is 2000 16-bit word. Here 544 16-bit word of double access memory. Here single access memory is 2000 number of 16-bit words are available. We know that if CNF bit is 0, it will be data memory. If it is 1, it will be program memory. Here you can see program memory map of LF2407, various interrupts. We know that what is interrupts. Interrupt is nothing but disturbing the main execution of the program, and we will be interrupting with any external device. All those things. In that various level of interrupt is there. According to the level, the priority will be given. We know that trap is nothing but having highest priority, non-maskable interrupt, that one, and a few software interrupts also is there. Those address and all address range will be mentioned. So if any trap interrupt has came, the program will shift to 0022H to 0023 memory location. This things CNF bit, configuration bit, then this also data memory map of LF2407, elaborately given that memory location. Event manager A is going to occupy what are the memory space: 740072, 7408, 74112, 7419. These are all the various memory space occupied by event manager A. Event manager B will occupy 75002, 7508. These are all the various memory space. So if the program, if they are asking you to write a program with event manager B, use event manager B. That means timer 3 and timer 4 you have to use, not timer 1 and timer 2. If they are asking you to write a program with event manager A, you will use timer 1 and timer 2. Then that corresponding address is 74002 to 7408. These are address we will be using. 75002 7508, 75 series and all event manager B. So this address you should remember. Then for memory, we have seen multiple spaces for memory. Similarly, input-output space. Some external devices requires memory space for the memory space for their purpose. For that, memory space is allocated from 0002 to FEFF. This is a space for your input output devices, memory map of input output devices. This is a complete architecture explanation of TMS320 LF2407 DSP controller, and event manager A and B also elaborately explained. Thanks for watching this video. Kindly give your comments, as well as you can subscribe this basic engineering YouTube channel for further updation and improvement of this channel. Thank you so much.